Hello, everyone, and welcome to this session of the Explore Mars Innovation Forum, where we are so fortunate to have Dr. Bhavya join us, who is currently the Senior Advisor to the NASA Administrator for Budget and Finance. In the first 100 days of the Biden administration, she was the senior-most White House appointee and acting chief of staff at NASA, as part of which she oversaw the agency's transition under the administration of President Biden. Bhavya, welcome to today's segment. It's so good to have you.
Thank you, Beth. It's absolutely an honor to be with you.
Oh, I'm so excited today. We're going to really get to have this wonderful conversation with you, and I can't wait to start it off. So we have big goals. NASA has big goals, and one of them is to start on the moon and move towards Mars. So what are some of the things that we plan on accomplishing on the moon that could lead towards our future on Mars?
Great question, Beth. So let me start by saying that Mars is our horizon goal. Being on Mars is a critical step to, in the words of former presidential science advisor Jack Marburger, to incorporate the solar system into our socioeconomic sphere. To continue this chain of thought, we've had a lot of successes in LEO, as you know. We've had continued human presence in low Earth orbit for over 20 years, and now there's, plenty of commercial activity in LEO. There are lots of things we've learned about being in space from being in low Earth orbit, but there is so much more. In my mind, after low Earth orbit, the moon is the next step to get to Mars. So as many of the audience members know well, as do you, our current concept for a first human landing to Mars includes a ship, I'm simplifying a bit, that will travel to Mars, remain in Mars orbit with 2 crew aboard, while 2 crew board a lander for their descent to the surface, in principle. Our current moon program, Artemis, has operations at the moon that would be very similar, providing astronauts opportunity to practice orbit-to-surface operations for years at the moon before embarking on missions to Mars. A second aspect of the moon that has direct relevance to Mars is a gateway. The lunar gateway will serve as a port in lunar orbit to validate proposed Mars transit habitat. Docking the transit habitat to the gateway for multiple years will provide increased habitation volume and help demonstrate autonomous spacecraft system management and long-term reliability of similar systems needed in a deep space environment. On the surface of the moon itself, we will practice how to live away, far away from Earth for long periods of time. As much as possible, our technologies and operations will be designed to serve dual destinations of both moon and Mars. Going to the Mars is going to be difficult. Mars is 2,000 times farther away from the moon. We will need technologies like advanced propulsion, rovers, space nuclear power, human habitats, in-space manufacturing, life support systems, in-situ resource utilization. I cannot finish the list in a single sitting.
Right?
And others to help us build these self-sustaining outposts in the solar system. And of course, the moon is where these technologies will need to be first developed and demonstrated. As I said at the start, I'm a believer that we need to incorporate the solar system into our economic sphere. And in order to do that, we need to start using local resources. The moon is a great test bed for what are called ISRU activities. I can keep going. The list of the ways the moon enables Mars is long. And we look forward. Let's discuss some of that.
Yes, I believe you. The list is long. And through my brief time at NASA, I had the privilege of working in the Spinoffs program, where you really get to see how some of these activities and innovations get to be applied. What are some of the specific ideas that these spinoffs we would be able to receive from exploring Mars?
Yeah, so but this is the incredible thing about science, as you know well, having worked in that program. Until we pursue it and further the development of technologies needed to get to Mars, we may not know what the payoffs will be. I want to give you 2 examples, though, one from the past and one from the future, and maybe that would help. So the Apollo program is the last time we went to do something, a moonshot. It helped spur the computer revolution. It led to the development of countless innovations we use on Earth every day, including, as I wore one this morning, cooling garments for use in medicine and sports, improved dialysis medicines, water purification systems, self-righting life rafts, flame-resistant textiles, personal locator beacons, and improvements to freeze-dried foods. And looking forward to Mars, here are a couple examples, both of which may have terrestrial applications. So on April 20th of this year, 2 days before Earth Day, I remember, an experiment called MOXIE produced 5.4 grams of oxygen on Mars. Basically, the device sucked in CO2 from the Martian atmosphere and produced oxygen. Of course, our goal is not to create grams of oxygen, but tens of thousands of kilograms of rocket propellant that will be needed to launch astronauts off the planet and back to Earth, as well as provide oxygen to breathe for astronauts. However, MOXIE's technology could be used on Earth as well. For example, it could be used at points where carbon dioxide is released into the air, such as smokestacks of power plants. A second example is the area that's an expertise of mine. On Mars, we know about months-long dust storms and day-night cycles, which make solar power less reliable. Remember, poor Opportunity rover couldn't even dust itself off after the solar storm. It went dead. So Mars provided this mission pull to develop a compact nuclear system. Such a system has application on Earth as well. For example, it could be, because it's lightweight and in principle mobile, it could be rapidly deployed to a disaster area on Earth. And we know already that the military has taken an interest in these portable systems because they may want to be having a need for power on forward bases. So lots of spin-offs from going to Mars, and most of which we cannot even imagine because this is how science works.
That's incredible. Is there any way we can take that system and apply it to children after the summer vacation to dust them off and get them prepped to go back to school?
Yes, that would be nice. I think some of those technologies are under development as well, like these special materials that deflect dust. So
that's incredible.
So I think we will be developing so many technologies that aren't worth developing by themselves. However, this pull of doing, pushing the frontier allows us to do things that we otherwise wouldn't consider doing.
Yes, and I'm really looking forward to seeing how that Mars incredibly improved food will be tasting. I'm sure everyone would enjoy something like that. And speaking of food, there's so many opportunities back on Earth for commercial sectors and particularly non-traditional companies that look towards these examples that you've given in the spin-offs that they can play in advancing technologies. Can you describe some that might have the potential of advancing sustainability on Mars?
Yeah, so the commercial sector has a pretty important role in advancing sustainability on Mars. Although I have to say this is a dangerous question to ask me, since so much of my work has been on what it means to be a commercial company and why commercial activities in space matter. And also, just to clarify, in this particular area, SpaceX doesn't count. SpaceX isn't going to Mars because it is a profitable enterprise. It is going to Mars because its founder thinks humanity needs to be a multi-planet species, which is more of a philanthropic goal rather than a commercial one. So let's take that one company out, and then possibly others that are not doing things for commercial reasons. So that brings me to what do you. So let's just use a broad definition of commercial, meaning a company that exists to make profit and put some skin in the game. For example, it brings venture funding or some other kind of funding to the table. I think commercial companies being brought into the game using commercial approaches, for example, fixed price rather than cost plus contracts from the government, can play a huge role in advancing technology. I do want to be clear, though, there are no customers on Mars other than governments of countries. And I mean, principally the US government and NASA. This is generally the assumption when commercial entities or approaches are in play, that there are customers other than government that a commercial company will sell to. And in this particular case, there really aren't any. Even if there are intermediate private companies that could be customers. For example, a company such as ULA may want to purchase propellant produced on Mars. or some other company may want to produce power on the surface, the ultimate customer is most likely a government.
Okay.
Having said that, I'm getting to your question. I believe it would be in NASA's interest and that of governments around the world to leverage commercial approaches to acquire products and services on Mars. There's growing evidence that approaches being proposed by companies today are more innovative, especially from a cost effectiveness perspective, than those being proposed by governments. And again, it's not an either or. There are some things commercial approaches will never accomplish. For example, a propulsion system to ferry astronauts to Mars may never be commercially obtained. However, it is feasible that we should try harder to make it possible that we purchase services like power and water in commercial ways on Mars.
Wonderful. Thank you. Do you think that any of these innovations that we are working to develop towards Mars have the potential of improving our life on Earth or even creating new markets for these innovations?
So that's a great question. I'll give two examples. One is a little profound. So going to Mars helps answer the fundamental existential question, the survivability of the human species. So now what do I mean by that? Exploring Mars will help us understand Earth's history, potentially understanding climate change, since we think Mars had more atmosphere and water but lost it. How did that happen? Could that happen on Earth? And the invariable follow-up question, how can we prevent that and ensure that we survive as a species? And I hope you would agree that saving humanity from extinction has in principle the potential of improving life on Earth.
Yes. Yes.
But I'll give you sort of a more sort of near-term example as well. And I think we talked a little bit about it before. So a journey to Mars will be long, right? 2 to 3 years, depending on the type of transportation we use. We need to develop extended shelf life food. As you know, well, food is edible after being stored for 3 years, but it loses a lot of its nutritional value over the time. Finding ways to stabilize stored foods would have applicability to disaster preparedness and help minimize food waste. So that's kind of a very specific example of how going to Mars improves life on Earth.
That's a great example. And again, I'm so looking forward to that. With your background in nuclear engineering, I'd like to ask if you think that nuclear power will be critical for long-term human presence. And if so, do you think that there are potential advances in these technologies as we look at some of the power challenges through the Mars lens?
Yeah, so that's another really great question, Beth. So as you know, Mars is 1.6 times farther away from the sun than we are, which means there is 50 to 60% less solar flux on the surface of Mars than Earth orbit. And as a result, solar power is simply not a realistic option, especially if we need a reliable source of power that doesn't shut off because a dust storm covered the solar panels, or there's a day and night cycle on Mars that makes solar power less available. There's also the challenge of size. Solar panels on the space station, I'm sure you've seen those pictures where they overlay the space station on a football field. That's how much that's how much area they cover. To produce that same level of power on Mars would require solar panels that are 2 football fields. Under the best condition, and maybe 5 football fields if we account for dust storms. And that means we need to take so much more material, these panels, to the surface of Mars. And given that we need 7 kilograms of propellant to transport 1 kilogram of usable payload, imagine the cost of this transportation. This will be a nearly impossible feat. So we absolutely need nuclear power on the surface of Mars. And as you may know, NASA is investing in the area. The administration is strongly supportive of surface power, and I hope we get similar support from Congress as well. To your question about where the technology is at, and the advance with respect to advances, the answer is well, it's yes and no. A couple years ago, NASA and DOE tested a small reactor called Kilopower at the Nevada test site, and the test went exactly as planned. And in principle, it could be scaled up to provide modular options for human exploration, and not just for Mars, but also lunar surface. However, at the moment, for a variety of reasons, NASA is focusing on a different technology, which is at a lower level of readiness.
Mhm.
But as I said, since the administration is strongly supportive, this is an area we hope we will continue to make progress on.
Fantastic. And there's a lot of opportunities for you as you lead us forward in your unique role to see a lot of these innovations. And so many things go through NASA, and you're quite able to help us navigate through them. So, which ones are you most excited about?
Wow, that's a hard question, Beth. I'm a tech geek, so there's a lot of innovations that I am so thrilled about. I guess let me give examples of 3 that I'm thinking about these days. And then the first one is just when I spoke of nuclear systems. So I'm excited about some work DOE is funding on 3D printing a nuclear reactor core. That kind of blows your mind.
Wow.
I know, right? So by
Yes.
by 3D printing, we can use technology and materials that the nuclear community that I have been part of for years has never been able to use in the last many decades. It includes sensors for near autonomous control, library of data, and a new approach to qualification that will benefit not just the space nuclear community, but the entire sort of terrestrial nuclear community as well. And so much worry we have these days about climate change and the role of nuclear power and mitigating. So the ability to 3D print nuclear systems would be really quite something. A second technology or a second innovation I'm super excited about is it's a suite of technologies called On-Orbit Servicing, Assembly, and Manufacturing, or OSAM. We can't take everything we want on a trip to Mars or even the moon. So we need to develop lower mass replacement parts. So we are not taking everything. We may need to take regolith from other celestial bodies, the moon, for example, to produce parts in space. We also need to be able to service and assemble autonomously. OSAM technologies, as I like to call them, will allow us to approach, inspect, grasp, manipulate, modify, repair, refuel, integrate, and build completely new platforms and spacecraft on orbit and on other planetary bodies. So as we push into the frontier, this innovation will get increasingly indispensable. And last but not least, the innovation I'm super excited about, and it's related to the MOXIE experiment I had mentioned earlier, ISRU, in situ resource utilization. ISRU will allow us to live off the land. As I said before, I believe, I wish someday we will be a spacefaring species, and living off the land using local resources is critical. So that's kind of my third innovation of choice.
Wow, those are 3 incredible innovations. And I'm so glad you're able to walk us through them, because we've heard these terms before, OSAM, ISRU, and I had not yet heard about 3D printing for nuclear systems. This is something new and exciting. I'm so grateful that we've got you to walk us through these and help us understand. And that is what the Mars Innovation Forum is all about. Dr. Lal, thank you so much for joining us today. I'm so honored that we got to share this conversation with you. Continued success to you and your teams and your work as you help us with innovating our technologies as we're working towards arriving at and surviving and thriving on Mars.
Well, thank you, Beth, for your time. I'm so excited to be part of the Mars Innovation Forum. I have been following your career myself, and I'm also excited to see where it goes. So I hope we have a chance to stay in touch.
Wonderful. Thank you so much.
Thanks, everyone. Bye-bye.